Hello guys, I'm Trockers. Thank you so much for tuning in. All candidates, this one is for you. If you want to level up your skills on integration in Taylor series, you are in the right place. Okay guys, this is a ZIMSEC June 2023 paper 2 question. It was number 12, part A. Given that I equal to integral of x squared over square root of 4 minus x squared dx. Using the substitution x equal to 2 sine theta, show that I equal to integral of 4 sine squared theta d theta. B, use Taylor series to expand cos x as a series of ascending powers of x minus a up to and including the term in x minus a squared. Hence, or otherwise, item 1, state the expansion of cos x in ascending powers of x minus pi over 6 up to and including the term in x minus pi over 6 squared. Find an approximate value for cos 31 degrees, given that 1 degree equal to 0.017 radians, giving the answer to 5 decimal places. Okay, let's get the ball rolling, guys. All right, so we are given that I, right? We are given that I, so this is 12a. We are given that I is integral of x squared over square root of 4 minus x squared with respect to x, right? We are going to use the substitution x equal to 2 sine theta. So now let's differentiate x with respect to theta, and we're going to get 2 cos theta, which implies that dx equal to 2 cos theta d theta. If we had limits, I would recommend to change them here as well, but just because it's an indefinite integral, then it's okay. So I equal to integral, remember x is that, so it's 2 sine theta squared over square root of 4 minus 2 sine theta squared, and we are going to change dx and we're going to write it with 2. We are going to replace it with 2 cos theta d theta, right? And now it becomes I equal to integral of 4 sine squared theta over square root of 4 minus 4 sine squared theta, right, times 2 cos theta d theta, which is I equal to integral of 4 sine squared theta over integral of 4 1 minus sine squared theta times 2 cos theta d theta. So I equal to integral of 4 sine squared theta over, so remember from this sine squared theta plus cos squared theta equal to 1. So cos squared theta is the same as 1 minus sine squared theta. So we are going to replace it. With that. So here it's going to be 4 cos squared theta 2 cos theta d theta. So I equal to integral of 4 sine squared theta, square root of 4 is 2, that one is 2 cos theta, 2 cos theta d theta, such that this and that will cancel out. So therefore I equal to integral of 4 sine squared theta d theta. So this is what we are supposed to show, and we are done with the first part, right? So now we are moving on to the Taylor's series. Moving on to the Taylor series, we need to understand that if a function f of x has continuous derivatives up to the nth order in the interval which contains x is equal to a, then at or near x equal to a, our f of x here, f of x will be equal to f of a plus f prime at a, x minus a plus f prime prime at a x minus a squared over 2 factorial plus blah blah blah, the general term fn a x minus a to the n over n factorial plus that, where r is the remainder. Right. So this is the formula, right, which can be simplified to f of x is just a summation from k equal to 1 up to n, right? Can I say 1 or up to k equal to 0? Should be 0 up to n of, here it's the same as saying fk a x minus a squared, right, over k factorial, right? Then in this case, you are going to see that this infinite series is called the Taylor's series about the about x equal to a, right? So now coming back to our question, right, where we need to find, so we are going to write the Taylor series of cos x in as a series of ascending powers of x minus a up to and including the term in x minus a squared. So the first thing, let's write cos x here. So cos x is our function. So function of x is equal to cos x, our first derivative, right? So when we differentiate cos here, we're going to get negative sine x. Then our second derivative, I think we are stopping there. If we differentiate sine, it's positive, but in this case, it's going to be negative cos x, right? So here, remember the formula, f of a is equal to, f of x is equal to f of a plus first derivative of a of x minus a plus second derivative of a x minus a squared over 2 factorial. So here, right, so this implies that our f of x equal to f of a is just cos a plus first derivative is now negative. So allow me to say minus sine a, then x minus a squared, right, plus here it's gonna be, if I expand that, f prime prime, that's negative again, so plus negative cos a, then x minus a squared over 2 factorial is just 2 minus 1. So we have expanded that in powers of x minus a up to and including the term in x ways, which is just cos a minus sine a, x minus a, not squared here, sorry, it's just x minus a, then minus cos a over 2 x minus a squared, right? Then moving on now, this was B, right? Then C item 1. So C item 1, it's saying hence state the expansion of cos x in ascending powers of x minus pi over 6. Right? This was x minus a. So here when x, remember x is now pi over 6. So what is cos pi over 6, which is cos 30, that's root 3 over 2. Sine pi over 6 is just 1/2. Right, so when you come here, it's going to be f of x, or cos x actually, right? Let me just say cos x equal to cos a, which is cos pi over 6. Well, let me just say cos pi over 6 minus sine pi over 6 x minus pi over 6 minus cos pi over 6 divided by 2 x minus pi over 6 squared, which is equal to cos pi over 6, that's root 3 over 2 minus this, that's 1 over 2 x minus pi over 6, then minus this one here, it's root 3 over 4 x minus pi over 6 squared, right? So we have, in this case, we have written cos x in ascending powers of x minus pi over 6. Okay, so now after this, we want to move on to item 2, where we want to approximate the value of cos 31 degrees, right? But there's one thing, guys, that we need to bear in mind, that 31 degrees is the same as 30 degrees plus 1 degree. And we know that 30 degrees is just pi over 6. Then we are told that pi over 6, in this case, we are told that 1 degree is 0.017, right? So when I say now x minus pi over 6, remember in this case, x was equal to 31 degrees, right? So which is just, we can write this as, okay, x equal to pi over 6 plus 0.017. That's our x, right? So when I say x minus pi over 6, it's going to be 0.017. So coming back to this, for 31 degrees, it is the same as saying cos pi minus pi over 6. So let's go back here to cos x. Our x is 31 degrees. So we know that cos 31 degrees is equal to root 3 over 2 minus 1 over 2. But we know that x minus pi over 6 is 0.017, then minus root 3 over 4, 0.017 squared. Then if we simplify this with the calculator, what do we get? Square root of 3 over 2 minus 1/2 times 0.017, right? Minus square root of 3 over 4 times times 0.017 squared. Okay, I'm getting 0.857275122 but they said to 5 decimal places, which is 0.85728, right, to 5 decimal places. So this is what we are getting, guys, to 5 decimal places. If we have done the correct thing there, 0.017 square root of 3 over 4. Okay, let me verify again. I think I made a mistake here. It's supposed to be a square root of, okay, sorry about that. Okay, so it's supposed to be square root of 3, then the 4 is outside. Okay, so square root of 3, then over 4. Okay, sorry about that. Okay, square root of 3. So square root of 3, right, over 4 times 0.017, right, squared. Okay. Okay, it's not this one. So it's gonna be, let's fix this out. Okay, so here it's going to be 0.857400261, which is equal to 0.8574025 decimal places, right? So this is our answer, guys, to 5 decimal places. So A-level candidates, we need to stay on top of the game. So make sure you do a lot of practice on integration and you know all the integration techniques, and also you master your game on what do you call this, Taylor series. With that being said, guys, I'm signing out. Thank you.